really common in data center design. So among the discussions, most of the time what comes out is the layer 2 is one of the key components that plays the most vital role in the data center designs, right? So we'll be discussing a bit on that, and we'll be seeing how Fabricpath functions, what are the different things that we need to look into, how it's configured. We'll also have a demonstration session for Fabricpath. So let's see how it goes. All right, so traditional data center designs, right? So traditionally, all the data center designs were segregated based on different pod sections, right? As I told, most of the features or the benefits of that we can see or that are generally used across data center designs is the most important and the vital is the layer 2 features, right? Because of layer 2, there are certain reasons why we choose layer 2 or why is it important in the data center. Some of the reasons are like, it's very simple. It's almost plug and play. You attach a switch to the network, STP comes into play, and it does its, runs its algorithm, does the blocking, or makes the forwarding decisions, right? Again, no addressing is required. It's easy for, it makes it easier for provisioning servers in the data center. It also helps with the mobility over the virtual machines, right? Because you have a layer 2 domain, and it doesn't matter where you're moving within a virtual machine within that domain, or even for a different domain itself within that same data center location, right? So it helps in that as well. Also, a lot of protocols rely on the layer 2 functionality. So even layer 3 protocols, and most of the times, and most of them rely on the layer 2. So if your layer 2 isn't there, layer 3 isn't going to work, right? So in each layer data center design, the problem with the older traditional designs was all the benefits of the layer 2 features was segregated only to the pod itself. So whatever the benefits you had, you could were only limited to a particular data center location or the segment that was created for that pod, right? What is the alternate solution to this? Is you expand the layer 2 network. So bringing on all the pods together and creating a big STP network, but that again has its own challenges. Now, what are the challenges? Now, some of the challenges are and the biggest challenge is with the STP, right? The convergence with the STP is not very scalable and it's not very smooth, right? Because of the STP, a lot of the times in the data center or in the layer 2 environments, there are chances of creating a loop kind of situation, which actually creates a lot of problems within the layer 2 domain and causes disruptive behavior. Right. So again, apart from that, MAC address table is one of the limitations because with the number of hosts, you have to scale the number of MAC addresses supported within the MAC table. Now, every device within the layer 2 topology has to maintain that amount of MAC table to do the forwarding and the lookups, right? Tree topology. The tree topology, you had a limitation on the bandwidth, and obviously it was it also introduces the suboptimal paths, which causes some delay or latency in the forwarding. Apart from that, it doesn't provide you with the ECMP features, equal cost multipath features. So you cannot do, you cannot share traffic across multiple links, right? So again, the forwarding is slow. Most of the time, for STP to work properly, the flooding has to be enabled, right? And with the flooding in the whole network, really causes a lot of impact, because sometimes you see broadcast arms, you can see unicast arms. Even if you're running multicast, you can see multicast arms, right? But generally talking about the layer 2, you are the layer 2 network is prone to such kind of storm attacks and impacts that really impacts the whole network, because if the storm is affecting one node, it is definitely going to affect the other nodes because of how the STP and the MAC table flooding works, right? Also, as I mentioned, if one node is impacted, it is going to impact multiple nodes within the network, so it's going to create a bigger impact and causing a bigger outages in the production environments, right? The solution to this that Cisco has come up with is the Fabricpath, right? There are other technologies as well which works similar to Fabricpath. I can name them, but we are not going to much into discussions of those, because they work side and side with Fabricpath as well. Technologies like Trill, which is a technology which is recently boosting up a lot. Apart from that, nowadays we have features like Fabricpath or VPC, which are introduced in the data center designs. They have their own benefits, but Fabricpath is one protocol or one feature that actually works based on, or which provides the functionality or the features and the benefits of both layer 2 and layer 3, right? So we'll see how that works. All right, so Fabricpath, as I said, it provides the features of both layer 2 and layer 3. So what are the benefits of layer 2 that we discussed? It's plug and play, easy to configure. You have flexibility of provisioning virtual machines, or adding or removing hosts, or mobility across the data center. Those are the benefits that we get out of switching mechanism. With the routing principles, we get the faster convergence, right? More scalability. Apart from that, we have ECMP path features. Now, Fabricpath provides both of these features. How? Because Fabricpath has its control plane running based on layer 2 ISIS, right? You don't need to configure it. It's all automatic. It takes care of the routing and provides you with ECMP features. So in order to reach a particular location, you will have multiple paths to go around and route the traffic accordingly, right? Any questions? Okay.
Continue.
All right. So the Fabricpath, there are different terminologies that we need to keep that in mind, or are mostly helpful when we are talking in terms of Fabricpath designs. The first is the Fabricpath, the spine switch. The spine switch are more like the core switches in the data center, right? So spine switch only provides Fabricpath nodes to Fabricpath nodes connectivity. They do not connect to any layer 2 networks like any other switches which are not part of Fabricpath, right? They only connect to the Fabricpath nodes. Then there's the leaf switch, which connects to the Fabricpath core, but at the same time, it also connects to the classical Ethernet environment, that is where you can run STP or any other layer 2 protocol for that matter, right? You have the Fabricpath edge ports, which are towards the classical Ethernet, and you have the Fabricpath core ports, which are towards the spine switches. These ports are generally that we call on the leaf switch, right? On the spine switches, we only have the core ports, nothing else. Within the core fabric, you run ISIS. Here, you can run STP or MST, whatever you want to run, right? Right? So what happens there? The classical Ethernet environments sends regular Ethernet-based frames. They run HTTP to MAC learning and all the populating the MAC address tables. On the spine switch side or towards the core side, it only understands the Fabricpath frame. It does not understand any MAC. It does not maintain any MAC tables. It does not run STP. It only maintains its own routing table computed by ISIS, right? And as I said again, you don't need to configure ISIS. It's all automatic, right? So how Fabricpath works? Now, Fabricpath, what happens is when a switch or when a host sends a frame or a packet sourcing from in order to reach from A to B, right? This frame reaches the leaf switch where this packet gets encapsulated within the Fabricpath frame, right? And based on the routing decision within the Fabricpath core, it is then forwarded towards the destination switch or the leaf switch where the other host resides. And that is how the Fabricpath forwarding takes place. Within the core, it runs its own shortest path algorithm to understand which is the most shortest path to the destination leaf switch. And based on that, and remember, it is not going to make the decision based on the MAC address. It is going to make the decision based on the switch ID of the destination switch where the destination MAC address resides. I'll explain you on a whiteboard how that works, but we'll do that further later during the presentation. Okay. All right. So in the control plane, what we are running is the ISIS, right? It is based on the ISO IEC 10589 standard. Apart from that, it's just a layer 2 ISIS. It's not even a layer 3 ISIS, so you don't even need to remember that. But yes, you can look into the routing table of the Fabricpath using the show Fabricpath ISIS route commands to understand how the routing looks like and which paths are being taken or which paths are available to the node in order to forward the traffic. Right. Also, the control plane provides you with ECMP features because it's running on layer 2 ISIS. So ISIS, using its link state features and algorithm, it's providing you with the ECMP features and provides you with all the paths that are available to you to reach a certain destination. So if you see the Fabricpath routing table, you will notice that on switch 100, switch ID 100, you have 4 paths in order to reach switch ID 400, right? You have a path L1, you have a path L2, you have a path L3, and L4, right? From here, they can choose among the best path to go to the destination of switch ID 400. And they can also do ECMP if the costs are equal, right? For any switch IDs, you will be able to see that it's providing its interface which are available to you, and you will be able to see their metrics as well in the command I told you, show Fabricpath ISIS route, right? So generally, all the routing decisions are taken by the ISIS, and you have no control except for changing the metrics. You have no control on the decision making. Because it's all decided upon the shortest path. Unless you modify the metric or play with the metric, yes, you can control that. But apart from that, no. Right? Any questions? Okay. So just to further clarify, so what happens is within the control plane, what the switches does is they send a layer 2 ISIS update to and forth to each fabric nodes to communicate and share their information across, right? So if you have like this port is connected to a CE port, right? All the information will be shared using the ISIS update, right? And thus, no STP is required within the core because all the update is going via the ISIS. So you're replacing the STP from the core itself, and you are expanding your layer 2 domain. And for that reason, only this switch, and suppose the host is here, B, and this side you have a host A, only these two switches are the ones who need to know the MAC address of the locally connected host. No other device in the network needs to know that. All these devices only care about the ISIs or the Fabricpath switch IDs, and they do their forwarding decisions only based on that, nothing else. Right? Also, you might not find that in the presentation, but I just want to let you know that within the Fabricpath topology, since it's running ISIS, you have the capability of managing multiple topologies. Like you can have certain topology, say let me remove this up, right? So you can have a topology from this side to this side, right? This side to this side, this side to this side, this side to this side, right? And suppose there's one more switch over here. You can run a separate topology on this side. So make it empty multi-topology 1 and multi-topology 0. You can have two different topologies, right? And they can maintain their own forwarding decision. The same way like you have with ISIS, right? You have the multi-topology capabilities. So you have the same features available in Fabricpath as well, right? Any questions? All right.
No.
So continuing with the data plane. Now, the data plane is very interesting. So as I was telling you, as the host A sends a frame, so MAC A to MAC B as the destination, right? In the Fabricpath core, it is not seen as the MAC frame or the layer 2 frame. What it is seen as is it's A connected to B. This is encapsulated within the outer header, and here it says I want to go from switch 100 to switch 300 or 200 for that matter, right? Wherever it wants to go, right? So like you see here, and it will make the forwarding decisions based on its Fabricpath routing table, right? So whatever the control plane has learned, based on that, for the data plane, the association MAC address, the edge devices only maintains the association of the MAC addresses and the switch IDs to help forward or map the traffic from one end point to the other end point to forward the packet to the right destination, right? Apart from that, only the ISIS is doing the forwarding decisions. Now, if there are multiple paths, based on the control plane, the forwarding will take place accordingly, right? So how does the Fabricpath frame look like? So this is the layer 2 payload or the layer 2 frame, right? Classical Ethernet. Now this is actually get encapsulated within the Fabricpath frame, where the Fabricpath frame has the outer destination address, the outer source address, the FP tag, and the CRC, right? Now, what really the Fabricpath frame has, right? So the outer destination address contains the end node ID, the UL bit, the IJ bit, end node ID again, RSVD, these are the reserved. So most of the common ones which come into use are the switch ID, the subswitch ID, the LID, right? The subswitch ID is generally used when you're running VPC plus. Oh, sorry. right? Otherwise, this the subswitch ID value is always set to 0. If you are running VPC plus, it's only then this value is going to change. The switch ID is actually based on, now if the destination switch ID is value, say 200, this value will be changed. Now the LID, I'm going to discuss in more detail. It is, the LID actually identifies the destination of the source interface or the source interface, right? Now, where it needs to go, where is it coming from, all that is maintained via this LID. The FP tag is also one of the important features or the important part of the frame, because this really helps you with the forwarding decisions. Note that the Fabricpath Ethernet type is 0x8903. So if you do some kind of sniffer capture within the Fabricpath topology or within your network, right, and you capture the frames, if you see the Ethernet type as 0x8903, that means it is a Fabricpath frame, right? So apart from that, you can see a TTL bit. Now remember that the TTL bit here is the mechanism or the way they are trying to avoid any kind of loop situations, right? I'm going to discuss more on how it actually works on the loop. So say for there's a switch here, right? There's a switch here, and there's a switch here, and they're running Fabricpath over here. So what happens is the frame goes from here with a TTL of 3, right? From here, so TTL of 2, right? So here it received the TTL of 2 and follows the frame. Now the TTL is decremented at every hop in the topology. Now when it reaches here, it is already at TTL 1, right? And so when the frame is again trying to get forwarded to this node back over here, it says stop because the TTL is 0 and drop the frame. So this is how it's actually avoiding the loop. It's the same mechanism how it's how we avoid the loop and the routing environments, right? So with the help of TTLs. So the same way it's being done over here as well. All right. So it's really important to understand what are the contents of the Fabricpath frame, because generally in production environments, when we troubleshoot it, if we know how to read the Fabricpath frames, it becomes more easier to troubleshoot sometimes routing issues in the Fabricpath network. Though there are very less scenarios wherein it may run into issues, but yeah, I mean, it definitely helps to understand the how the Fabricpath frames look like, right? So what is LID? Now, LID is one feature or one value which removes the need for having or which removes the need for MAC learning on the core ports, right? Because it keeps a tab on what is the source interface and what is the destination interface, right? If you don't have the LID, you will have to rely on the MAC addresses to understand where the frame needs to go and do MAC lookups and all that stuff. But with LID, you completely, what you really do is you encode the MAC address into the Fabricpath MAC and MAC frames. Right. So this is again locally significant, and it is not something which is common to multiple nodes within the network. Right. So whatever the value of LID is, it may be locally, and you can see that value based on the Fabricpath routing table or the MAC address table as well. So if you do a show MAC address hyphen table and look for particular MAC addresses, you might see that the entries might be in the format of the SID, the switch ID, the sub-switch ID, and the LID format, right? So you need to remember this format. This is mostly used in Fabricpath environments to troubleshoot where the MAC is being learned and where it's being forwarded within the Fabricpath domain. right? Other important aspect or the value that is important is the F tag. It's a unique 10-bit number which is used for identifying the topology or the distribution tree. It's again integrated within the Fabricpath frame itself, and it's generally automatically set. So for unicast packets, identifies which Fabricpath ISS topology to use, right? Now, you might have different kind of frames like broadcast, multicast, unknown unicast, and based on those different kinds of frames, the different F tag values are set, right? So based on the F tag values, the device, the edge device understands what kind of forwarding it needs to be done and where it needs to be done, and what processing has to be done on the packet to make the further forwarding happen within the Fabricpath topology. All right. Now, the regular Ethernet VLANs, we have been reading in all the switching environments, and we have been doing that in routing and switching, right? Now, with the Fabricpath, the regular Ethernet VLANs are no more supported, right? So to have the VLANs being able or capable of getting forwarded or being learned across the Fabricpath topology is you need to enable the mode Fabricpath for that particular VLAN. Now, if you go into the VLAN and you do not set any mode, it is by default the classical Ethernet frame of based VLAN. But if you set the mode to Fabricpath, now that VLAN will understand that it needs or it will be treated by the Fabricpath topology and not by the classical or the traditional STP-based topology, or the forwarding will be based on Fabricpath itself, right? For Fabricpath, the F-series modules are supported for the edge and the core ports. For the Nexus 5500, you don't need specific modules. It's supported on that platform. You only need to enable the feature Fabricpath in order to use Fabricpath within the core topology, right? So if you do show feature, pipe include Fabricpath, you will be able to you will see that it is disabled by default, and you need to enable it, right? ECMP. Now, ECMP is again taken care by the control plane ISIS, right? The maximum number it supposes up to 256 links within the topology, and it is between the two edge devices. Note that you still have control over the maximum number of multipathing that you need to do. So what you can do is you can go to Fabricpath domain default, right? And you can set the maximum paths as the number of maximum paths that you want to have within the topology, right? So based on your design, you can control the number of multipaths that you need to have, but otherwise it will do the default multipathing within the core on all the available links. I don't recall on top of my head if there's any default value of the number of equal-caught multipath links, but it should be 16, I guess. I'll check that and let you know. Okay. All right. So any questions so far?
Is there do we have to identify spine switches as spine switches, or there's no identification? Just
No.
when you have the core and the edge, then that's what you identify.
So you don't really need to identify the spine switches. The switches which do not have the CE ports are generally the spine ports. the spine switches.
Which ports?
Right. The CE ports.
Okay.
Connected to the classical
Edge.
Ethernet environment. Yeah.
Okay. Got it.
Right. So in the edge ports, you have two kinds of ports, right? The FP core ports, right, and the CE ports.
Okay.
Now the CE ports are connecting to the classical Ethernet switches or the host, and the FE ports are connecting towards the core. So any device which is only having the connectivity to other Fabricpath devices is the spine switch. Right? So if you see these two devices, it will only have connectivity to this and this. It is not going to have, and if it's going to have a connectivity to a CE device, then it is not a spine switch. It is edge leaf. I mean, it's a leaf switch.
Okay.
All right.
Thank you.
Yeah, no problem. So I was also thinking of taking a moment to explain on how the forwarding works in Fabricpath, right? Give me a moment. Let me pull up another window. Right? Are you guys able to see my screen?
Yes.
Okay. So let me draw a small topology to help you explain how the actual forwarding will look like from host A to host B. Okay. So make it 100. Right? So this is how the topology will look like, and the hosts are connected over here, A and B. Now what happens is the host A will send a frame or a packet with the source MAC of A, right? The destination MAC as FF, the broadcast, because right now it doesn't know the MAC address of the destination device, and obviously the payload, right? Now, it is received by the switch 100, switch ID 100, right? What it does is it populates its MAC table, so makes it entry in the MAC table as MAC table. It says, this is host A, right? This is the MAC address of host A, and it's learned over the interface, say E1/1. Okay. E1/1. Right? So it will populate its MAC address. Now, since this is an edge device, what it will do is it will treat the broadcast as that. Okay, over here I have, say, port channel 10, PO10, PO20, PO30, right? So it will have the shortest path. So it will have its tree built in the Fabricpath routing table, saying that I have a tree and the interfaces. Now the first tree is saying that it goes to Fabricpath to the switch ID of switch ID 10 with on port channel 10, right? And again, it will have another entry for all the destinations, so across the equal cost multipath links, right? So it will have an entry of port channel 10, port channel 20, port channel 30, right? So at this point, it will try to broadcast the frame, right? So what will the broadcast frame look like? Now the broadcast frame will look like, let me draw it with a different color. The broadcast frame will look like, this is on the switch 100 towards switch 10, right? So it will look like destination address as FF, right? It will set the F tag as 1 because it's sending a broadcast right now, right, within the tree. It will set the destination MAC address, below is the payload, right? So destination MAC address as FF, the same stuff that we had here. It will come down here, right? So it got encapsulated over here. It will also have an entry of the source address. So now the switch ID of 100 is the source address. So it will say that source address is 100. It's not having any VPC, so the subswitch ID is 0. And say for it has the LID as 100. Oh, sorry, not 100. Make it 10 or any random value, say 6, right? So it says that the source address is 100.0.6, right? So it knows from where the packet came in. This is the port which it says, okay, the packet is coming from this point. All right, so now the frame reaches the switch ID 100. It's also a multi-destination tree, right? So in the multi-destination tree, like this guy had its own routing table and the tree built up, it will also have its tree built up, right? So it will have entries like, one entry will have towards, say, this side is having port channel 100, port channel 200, port channel 300, right? It will have the entry of port channel 100, port channel 200, port channel 300. Right, and then it will also have another entry for port channel 100, the shortest path back towards this point, right? So at this point, it's actually the broadcast ARP request, and it is supposed to go out of all the interfaces. So after it has reached to this point, it is going to forward across the packets to all the entries in the first entry, right? So since the packet was here as well, here as well, here as well, it is going to drop the packet on this node, whereas on this node and this node is going to reach here. Now, as soon as the packet is reached to this point to switch 400, right? So what it will do is it will have its own, as I said, the tree built. The tree will have entries like 1 towards all the spine switches, right? Sorry. Spine switches. So S10, sorry, port channel 10, 20, 30, right? So it has 10, 20, and 30. It will have one entry for that, and it will have one entry towards the spine switch 30. So port channel 30, right? The same way, the same process that was happened on the left side of the topology, it's happening on the right side of the topology. Now, after the frame has reached to this point, right, it is going to decapsulate here and see that where's the source MAC of A was there, and the destination MAC is FF, right? Remember, at this point, the MAC table is not going to be formed, right? It is not going to be formed. So after this guy has reached over here, the frame has reached over here, it's going to respond back in this manner. So in the response back, let me use another color so that it becomes more understandable. Right? Now, returning path, the packet will look like the destination MAC is A, the source MAC is now B, and the payload, right? And the same process here. So it has built its MAC table now here, right? That it is learned over this interface. Now, when it reaches to this point, right, it knows that it has this tree over here available. So it will go to the point port channel 30, right, port channel 20, and port channel 10, because the first entry is towards all the port channels, right? After it has sent the packets to everywhere, right, what it'll say is the multi-destination point tree is already there, so it is going to reach back to the switch ID of A, right? And when it reaches here, it knows where its routing table is built, right? At this point, when the packet is forwarded back from here to all the rest of the nodes based on the port, the routing table, the Fabricpath routing table, it will have this kind of entry. So the destination MAC, the DA address will be.
One question.
Yeah.
Why doesn't it send the reply back from the port it received instead of multicasting it to sending it to everybody?
Because it doesn't know where it needs to send the packet. It hasn't built its own table yet, right? You can only see the MAC address of B. It's a good question, right? You understand that, I mean, unicast forwarding only takes place when you have both the source and the destination MAC address. Unless you have that, it is not really possible to have the unicast forwarding take place, correct? Make sense?
Yes, it does.
Okay. Yeah. So now it knows that when it forwards the packet over here, it says that the destination address is of the multiple channels. It's coming up the multiple destination addresses from here itself, because the packet, when it's sent from this guy to this guy, it already has framed its packet in a different way, right? So over here, when switch ID 400 sent across the packet to all the uplinks or the spine switches, it said that its DA address is MC, right? F tag is pointing to 1, right? The source address is similar way that we formed over here, right? 100.0.6. So it might have something like 400 dot 0 dot say 10 or 11, whatever value it may have populated when it's stable, right? And at the bottom of it, it will have the same packet that it was sending. So that is encapsulated, right? From there on, the same packet will be received here and will be sent across to the switch 100. Now, when the switch 100 receives it, it is then going to populate its based on the F tag, it knows that it is coming out of port channel 10 because it already has its routing entry built. And then it is going to populate its MAC address table, right, saying that the B is learned over 400.0.10. Make sense? This is how it will look like in the MAC address table. This MAC address table is only populated within the MAC address table when the destination MAC address is known. Now, when is the destination MAC address known? Remember, the destination MAC address now is A, and this destination MAC address was already populated in the MAC address when the packet was originally sent. This is how it is going to build up its MAC table.
Interesting.
Yeah, it is. So once it has reached to this point, it will have an entry of 400.0.10, right? Then it knows where it needs to send the packet. No questions. Then all the unicast forwarding will take place. All right. So any questions so far?
No, that was excellent explanation. Thank you.
All right. So I think I explained the one part of it. Now, if you think logically, and if you recall that this side of the MAC address table is not completely populated, right? It is only populated for the MAC address B. So next time it tries to send a frame for A and sourcing from A to B, the same logic will apply for populating the MAC table. The MAC address table will only be populated when the destination MAC address is found in the MAC table. So now when this guy sends a frame, the destination MAC is going to be B, right? And this guy already knows B. So it is going to populate its CAM table or the MAC table saying that the other entry will look like on this guy. The first entry of B was like B was learned over Ethernet 2/1, say, and now it will populate an entry saying that A is learned over 100.0.6. Was it the same one that we said? Yeah. Right? This is how both know each other, and then the uniclass forwarding will take place. Right. So I know it's a bit complex thing, but yeah, I mean, once you start playing around with the devices, it will become easier, and you will learn more. So definitely, a hands-on will be required. So any further questions, or shall we move to the demonstration?
Let's move to the demonstration.
Okay. All right. So let me stop the screen sharing.